Okay, so now let me play with some details of this solution. Because sometimes the whole process doesn't work and you don't get the integral. So what would have happened? Well, recording the discussion yesterday, our first guess, let me do it in red because I'm going to check, to change some conditions here, and I will come up with the wrong answer, but that will be our practice of watching what may go wrong and then figuring out why. So the first suggestion was to have the Hooke's law in this form, wasn't it? That's the typical way you think of it. The way spring becomes longer is proportional to the force applied. So if you try to apply that Hooke's law, what happens? Well, in this form, this change of the length of the short piece is equal to k times f without any delta x. And that makes this Li having that form. And that should immediately warn you that, oh, this is not linear on delta x. So there is a problem there. But suppose you didn't notice that and you proceeded with setting up the integral. Well, then you will have, you will not have this form. You will not be able to pull out the delta x and come up with the formula in that special form of something times delta x. Well, what's the problem with that? Why isn't that an integral? Is there any mathematical problem with this expression? Because if mathematics works well, even without delta x, well, maybe it's just a different setup. Maybe it's a different integral or something else. So what's wrong with mathematics? Is there something wrong? The limit doesn't exist. Right? So we know what happens to this part. What happens when you add all the delta x's along the whole string? Well, that will give you exactly the original length. Right? So limit of sums of delta x's is always L. No need to take the limit. The sum is always L, no matter how you subdivide. So the problem is there in the second term. So let's look at that. Limit as delta x goes to 0 of sums of over all i's of k times f of xi. So what kind of creature is that? So what you do is you subdivide that interval into pieces, right? And for each piece you make that number and you add up all these numbers. Well, the more you subdivide, the more numbers you get. And if you keep subdividing, keeping the old numbers, right? If I keep the old point of subdivision, I will have the old sum sitting inside. I will keep adding more terms. And then, what about those terms? Are those small? Are those large? So we hope for additional terms to be smaller and smaller so that the whole sum converges to something reasonable, to a number. Well, as we add, we always add something large. So that limit doesn't exist. So mathematics doesn't work. It's not about notation or our understanding. It just fails to work.